Hello. Finally, it's time to start putting this thing together. So in this video, I'm going to show you how to put all these parts together. At least that's what you thought, wasn't it? But my secret plan has been that by this point, if I've given you enough information, or if you've paid enough attention to all those previous videos, you should be able to just put this together yourself. So I was thinking to not really make a specific build video episode. And I'll just, I mean, I almost could just jump cut from having this in pieces to having it all together. And I think I've covered enough in previous videos for you to fill in the gaps. So that was kind of my plan, but there are going to be a few little points here and there that will still need some mentioning. So I think what I'll do is I'll just put this together mostly off camera, and when I come across something that I have not yet mentioned that does need to be pointed out, I'll just mention those little things briefly as I go. I guess the first thing to point out is the motor direction and the numbering. So if you look on the configuration page of the Betaflight configurator, you can see that the motors are numbered 1 through 4 in this arrangement. So this is looking down on the quadcopter from the top with the arrow pointing to the front. So the rear right motor is going to be number 1. And you can see from this arrow here that each of the motors needs to be turning in a specific direction. And these numbers here will let you know which pins to plug in the ESC for this motor on your flight controller. Now, depending on what kind of motors you're using, this may require you to put a specific motor in a specific position. So for example, you can see these motors are a little bit different. They've got different colored spinner nuts on them, or whatever you call these nuts. And that is because on this one here, when I turn this, let's see, when I turn it clockwise, it's going tighter. But this black one over here, if I turn it clockwise, it's actually going to remove itself. And this one, to tighten it, I actually turn it the other way, which I didn't do. Yeah, so to tighten it, it goes that way. That's right, yeah. So you need to put these on the correct motor so that when the motor spins, it's actually going to tighten these nuts. You don't want it the other way around, so that when you spin the motor up, the nuts will fly off. That would be a little bit bad. So the way you can check this is to just hold the nut still and then turn the motor in the direction that it will go when it's flying. Like this is the front left motor, so it's going to be going clockwise like that when it's spinning. So just turn it like that and make sure that that is going to actually tighten that nut. And over here it's going to be going that way. Well, it's already tightened. So that is important for those motors. And the other motors that I'm using over here, they are not like that, because they have a lock nut, or a nylock nut, which has a little bit of plastic inside the nut there, so that when you tighten it, it gets really tight in any direction. So you do not need to worry about which arms you're putting these motors on. By the way, just in case somebody does get this Armatan Productions frame that I designed, I would think that somebody as discerning and intelligent as yourself would not really need instructions, but just in case it wasn't obvious, the smaller screws, there should be 8mm screws and 12mm screws. The smaller ones will be for the standoffs, which you put on a pattern like that to attach to the middle plate. And then the longer ones will go through the arm base and be held on with lock nuts at the back. And another thing to keep in mind when you build the bottom part of the frame, when you put the legs on, they all need to be oriented the same way, meaning that these sort of diagonal slots, looking from the top, the diagonal slots should be going from bottom left to top right like that. And then when you rotate the next one around, that one should be the same. And this is just so that you can fit the motors on the right way, because the motors will have 16mm and 19mm spaced holes. And if you put the arms on upside down, then the motors won't fit on the right way. Okay, that's everything together now. I'm not going to put any of the FPV gear on just for the time being, and I'll put the battery underneath instead of having those plates on the top. So motors, ESCs, power distribution board and flight controller are on here now, and this is the bare minimum that we need to fly, plus a battery of course. And when you put the flight controller on, you'll find it easier if you notice the little arrow there, and that will be pointing forwards. It's not strictly necessary, but it will just make it a little bit easier when you come to setting up the Betaflight stuff later on. When you solder this onto your power distribution board, make sure you get it the right way around. I actually got this backwards one time and blew up the power distribution board. That was a bit embarrassing. Not really much else to mention. You should know by now where all the other connections go, and I've just plugged my ESCs in there, and I have my 5 volts coming up from below from the power distribution board, and that's just going into one of my spare ESCs plugs on this end of it. Now, most of the ESCs that people will be using these days will have just the 2 signal wires, so that's the black and white, the small ones, ground and signal there, just going out to the flight controller connector. But remember, we did also have this other type of ESC that has 3 wires on it, and this is the ones that have a BEC inside them, so that's a battery eliminator circuit. And what this does is it takes the battery power and it uses this little black box thingy, which is a voltage regulator, to drop that down to 5 volts to run itself, and it also puts that 5 volts out on this wire to provide power to whatever you connect on here, so your flight controller, for example. And that's all very well, but there's just one thing to keep in mind that I don't think I mentioned before if you're using this style of BEC, and that is that you cannot mix it with another style of BEC, such as this one that's on my power distribution board. So on the left hand side for my 5 volt regulation, we can see a bunch of stuff here, and this is a switching regulator, and it works in a slightly different way. The way this one drops the voltage down to 5 volts is it switches it off and on using a duty cycle PWM, so that it's on only a certain percent of the time, and the rest of the time it's off, excuse me. And that percentage will dictate how far the voltage drops down. So it's going to change that switching off and on so that it settles to about 5 volts. And that's very efficient because it doesn't waste any power that's not necessary. Whereas the linear regulator, so you see another one here, there's another black box there. This one actually has a 12 on it. You can maybe just see that on the right hand side. And that is a 12 volt linear regulator for this part here. And they've used a 12 volt here because these are cheaper, and we're not wasting so much power as heat. So what this is going to do is it's going to drop the voltage down from, say, 16 volts to 12 volts. So it's only 4 volts that's going to be wasted in heat on here, as opposed to 11 volts if we dropped it from 16 down to 5 on the switching BEC, on the 5 volt side. So that's why they have a switching BEC there and a linear BEC, or linear voltage regulator, on this side. But anyway, back to this thing. You cannot mix the linear regulator and the switching regulator. So you don't need to either, because you only need one. So from somewhere, you're going to have to get 5 volts from somewhere, but you only need one of them. So if you are using one of these, what you're going to need to do is get rid of this central wire, so you can pull out the middle of the wires there by, you know, the trick we did before with the knife before. It's not focusing. There we go. Just lift that up and pull the middle red wire out so that it's not going to be connecting to the flight controller if you're using a switching BEC like that. You can actually use, if you're only using this type to power your flight controller, you can leave all of them connected, because linear regulators can work together with each other. They just can't work together with a switching BEC like this. But to be on the safe side, or the short and sweet way to describe it, is you only need one. So you might as well just connect up one of these and remove the red wire from the other 3 of your ESCs if you're using ESCs with the BEC in them. To attach the ESCs, I just put a bit of double-sided tape under them and then wrapped some electrical tape around them. This has turned out to be a pretty good method in my other builds, so I'm probably just going to leave it like that for good, actually. And I found that I needed to cut away a little bit of the frame of this piece here just in front of the USB cable so that I could get the plug in there. It was a little bit too low. I used some of those plastic nylon spacers to separate the power distribution board from the flight controller, so you don't want to have those touching together underneath. So for the carbon fiber frame, everything's pretty much the same to this point, but you need to be especially careful that you do not screw these motor mounting screws all the way, or you don't screw them in so far that they hit the copper windings inside there that we can't focus on. There we go. So you do not want to screw into those copper windings. Well, this goes for the nylon frame as well, but it's especially important for carbon fiber, because on the nylon frame, if you screw these in, might find that the motor still mostly works, but the trouble with carbon fiber is that because it conducts electricity, if you do that on this frame, you're going to find that the electricity will be able to come down through this screw and into the frame, and then you've got some current going possibly back into this area and getting into places that you don't want it to. So that is extra bad on a carbon fiber frame, and that's why I find these motor mount things can be kind of useful. If your screw is a little bit too long, you can put this under the motor, and that gives you an extra about a 1 millimeter or so of spacing. And on this one I'm going to be placing the power distribution board flat against the body of the frame with no spaces, and that can also give you problems if you don't insulate this electrically. So I'm going to put some electrical tape across all the way across the bottom of this before I stick it down, to make sure that no electricity can get between the frame and the PDB. One problem I've had a few times in the past is that after a while of plugging and unplugging these battery connectors, the little gold connectors there with the 4 separations, they can kind of get squeezed into the center and they don't grip the battery very well, so sometimes you can be flying and it just slips out and then you crash. But you can get around that by poking something soft and spongy in the middle, and probably the best thing that I've come across is a little piece of the shielding from the silicone wire like this, that you just cut a little bit of that off and take the wire out from the middle. And I've actually had to split this a little bit thinner as well because it didn't quite fit. But once you do that, it means that even when those little prongs get squashed in, they can't really go in all the way, and they tend to bounce back out and hold grip onto the battery better, so that it makes a nice solid connection. Makes it a little bit harder to get in and out, but it's preferable to crashing, I think. To connect up to the FPV gear, I'm going to put this little JST plug also onto the power distribution board as well. So this is going to take the battery voltage directly out to here, and just makes it a little bit more convenient to plug in and unplug if you want to take the top part of the quad off later on. I actually forgot to do this on the other quad, so I'm going to have to go back and do that. On this one I'm not going to put the pins onto the flight controller, I'm just going to solder the wires directly onto the solder pads like that. And I'm using some of these little rubber grommet things in between the two boards, and they're just these little things like that. And some people like to do this to give the flight controller a little bit of cushioning to reduce vibrations, but I don't think it really reduces vibrations that much anyway. But the reason that I do it is because they squash down a little bit, and it helps these nuts to stay pressed. It gives them a little bit more of a lock nut sort of a function, so they don't tend to come off as easy as if they were down onto just a hard point. So I had to open this one up and do a little bit more work on it. So this is the one that I had originally. This is the 5 volt and ground that's going to be used to power the flight controller. And then I stuck another ground and positive, so this is whatever the battery is going to be, and that's to power the video transmitter on another one of those kind of plugs. And then over here I have a second main battery power voltage here, and this is going to go onto the flight controller to let the flight controller know what the current battery voltage is. So if you do that in the same way that I did, you're going to have 2 of these type of plugs coming out, and they're both going to look the same. This one over here is 5 volts, and this one over here is going to be directly from the battery voltage, so it'll be 12 or 16 or whatever. And you really have to get this in the right place, because if you put 12 volts into the wrong place on the flight controller, you're just going to ruin it. And for this particular flight controller, as we saw on the back labeling, we have a ground and a VBAT, so that's where this one's going to go there. And just another thing I might mention about these plugs, if you find that they're a bit loose, you can pull them like this. Can we focus? Yep. And just sort of use something sharp to push that little metal tab at the front in a little bit, just a little bit. Don't do it too much, because otherwise you might actually break it. But even if you don't break it, you can make it quite hard to push onto the pins. But if you just push it in a little bit, you'll probably find that when you plug it on, it's quite a bit more secure. So if you got that VBAT connection the right way around and the voltage is coming through correctly, and you didn't blow up your flight controller, when you connect a battery up, you should see in Betaflight this little display at the top showing you the current voltage of the battery. It actually shows down there as well. This is not actually necessary. This just lets you set an alarm value. So if we go to the configuration tab, we'll see down here somewhere we can set a voltage at which the buzzer will start beeping to let us know that we should stop flying, or let us know that it's getting low and it's time to start thinking about landing. Okay, after this point we're getting mostly into Betaflight setup stuff, so I wanted to cut the video here so that the next video will be mostly about Betaflight and less about actual construction, so that people who are approaching this video totally out of the series might be able to just use it for Betaflight setup help instead of having to worry about the rest of this build that I'm doing. Anyway, see you in that video.